Hello guys, welcome to my channel. So after so long I have come to this session on the exercise of function. In the last class we have also done some problems on functions. Now I will like to start from the question number 2. So here it is. Which of the following functions are injective and surjective? We have already done number 1. Now let's start from 2, that is a function f from z to z where fx is defined as f of x equal x square. We have to check whether this function is injective or surjective. So let's proceed. Let us take two elements x1 and x2 in the domain, the set of integers. Suppose f of x1 equal to f of x2, that is, the image of these two elements are equal. Now, as defined above, here f of x1 implies x1 square equal, similarly f of x2 implies x2 square. Now we solve this, right? This is in the form a square minus b square. Therefore, a plus b into a minus b equal 0. And this implies either this part equal to 0 or this part equal to 0. Where x1 equal to minus x2, x1 equal x2. We have a process where we take two elements in the domain set, and if we suppose or assume that the image of these two elements are equal, and if we finally conclude that the elements are equal, then we can say this function is 1 or injective. But finally we have got x1 equal minus x2 and x1 equal x2. This is satisfied, but this is not satisfied as the process to show injectivity. Therefore, this function f from z to z defined by f of x equal x square cannot be injective. Therefore, f cannot be injective. Now, to show onto, let y equal to fx. That means the image of the element x equal to y. And this is nothing but x square. Or we can write x square equal to y, from where we get x equal plus minus root over y, right? Now root over y, this cannot be an integer. That means x equal plus minus root over y. X does not belongs to z, wherever y belongs to the codomain. Therefore, this function f is also not surjective or not onto. So here the whole question is, this function f from z to z defined by f of x equal x square, this function cannot be injective or 1, 1. As well as this function is also not onto. So the question number 2 is done. Now question number 3 is f from z to z f of x equal x cube. And this is very similar to the question number 1 and 2. Therefore, I am skipping this. So this is for homework. Next question is f from w to w f of n equal n plus 1 whenever n is even and n minus 1 whenever the number n is odd. So we have to check whether this function f is injective or surjective. Now let us take two elements n1 and n2 belongs to the domain set W. Let f of n1 equal f of n2 and say this n1 and n2 are even. Case 1. So according to the definition of this f, here we have n1 plus 1 and n2 plus 1 since n1 and n2 are even. Cancelling out the 1 on both sides, we get n1 equal n2. So in this case, this function f is 1, 1 or injective. Case 2, let n1 and 2 belongs to the domain set W whenever these numbers are odd. Suppose f of n1 equal f of n2. According to definition, f of n1 equals n1 minus 1 and this equals n2 minus 1. Finally, n1 equal n2. This minus 1 on both sides cancels out. Therefore, f is 1, 1 or injective. So, on both the cases, whenever the numbers are even or odd, this function f from the set of whole numbers to the set of whole numbers, this function is 1, 1 or injective. Now for on to, let f of n equal y for any number n. Let's say this number n is even. Now for on to, let us take f of n equal y where n is even. And f of n is nothing but n plus 1 whenever this n is even. Now y equal n plus 1. We write n in terms of y. N equal y minus 1. Similarly, when n is odd, f of n equal y. This is nothing but y equal n minus 1 and n equal to y plus 1. So in both the cases, this function f is also onto. Because the number n belongs to the domain W whenever y belongs to the set W, that is codomain, and hence y is belonging to the range set. which is also W. Therefore, in this case, f from W to W is surjective or onto. So, this question is done. So, I hope you are understanding, and if you are not, then let me know in the comment section, please. Now, come to the question number 3. The question is, examine whether the following functions are 1, 1 or not. We have some functions which we need to check whether these functions are 1, 1 or not. We have to check injectivity only. The first question is, function f from z to z, where f of x equal x square plus 5. We need to check whether this function is 1, 1 or not. Let us take two elements x1 and x2 belongs to the domain set Z. Then f of x1 equal f of x2. According to definition, f of x1 equals x1 square plus 5, and f of x2 implies x2 square plus 5. This 5 cancels out. We get x1 square equal x2 square. On solving this, we get x1 equal plus minus x2. Since here this negative sign also comes, therefore we cannot say that this function f is 1, 1, because here x1 is not equal to x2 only. x1 equal minus x2 also. Therefore, this function f is not 1, 1. Let's jump to the next question. A function f from R minus 3 to the set of real numbers R, and defined as f of x equal 5x plus 7 divided by x minus 3. So here the domain set is R minus 3 and codomain or range is R. Now to check injectivity, let x1, x2 belongs to R minus 3. Then f of x1 equals f of x2 implies f of x1 implies 5x1 plus 7 x1 minus 3, and f of x2 implies 5x2 plus 7 divided by x2 minus 3. We cross multiply it, then it becomes and right hand side equal to 5x2 x1 minus 15 plus 7 x1 minus 21. So 5x1 x2 5x1 x2 cancels out, minus 15 cancels out, minus 21 cancels out, and finally we have 7x2 equals 7x1. So we get 7x2 equals 7x1, which is nothing but x1 equals x2. So this function f is 1 1 or injective. So the function f from r minus 3 to r defined by f of x equal 5x plus 7 divided by x minus 3. This function is 1 1. So this is done. So I hope you get it right. So I am ending this session here. If you have not subscribed to my channel yet, then do subscribe to my channel and also press the bell icon to get updated. That's all about this video. Thank you.